Now our next topic is to discuss what are rational functions. Okay, so in rational function the ratio word is included. It means that it has something to do with the ratio. So rational function means it is the ratio of two functions. Okay, so we will define properly that a function fx of the type or of the form fx equal to px upon qx, and where qx, look at, where px and qx are polynomial, or I can, whenever you write a numerator upon denominator, always just put a restriction that qx should not be equal to 0. All right, because the denominator for the values, the denominator is 0, those values must be included from the domain. Okay, that we will look by selecting one example, just to define first what is the rational function. Okay, so fx is equal to px upon qx, इस टाइप का जो भी फंक्शन हमारे पास होगा where qx is not equal to 0 and px and qx are polynomial function, and px and qx are polynomial function, or I should write here where. Okay, where will be more appropriate. Okay, so also you need to look at what language we are using. That will help you to clearly understand the definition what it says. Okay, so px and qx are polynomial functions. All right, so now we will, so this type of function is called rational function. So domain name we will look at further, but first we will first we will look at what are the examples of the rational function. So first example is, my fx will be what? X upon x plus 1. All right, so x is a polynomial also, because the degree of this polynomial is what? 1 and x plus 1. Okay, so the degree is same. Okay, so what should be here, that x plus 1 should not be equal to 0. Okay, so whenever you do this just put a restriction that x plus 1 or the denominator should not be equal to 0. Another example I can write in this way, that x square plus 1 divided by x square plus 3x plus 2, and again x square plus 3x plus 2 should not be equal to 0. All right, so these are the two examples. In this way you can frame more example. Now we will look at the domain. The domain first. Domain of a rational function. So again we will recall the definition of the domain of the function. So for example, I can select this one. Now fx is equal to x upon x plus 1, and already we have shown that the denominator should not be equal to 0. Okay, so just for the domain of that function I need to look at the collection of all real numbers such that my fx is what? Such that my fx is a real number. For different values, naturally fx will give you a different value. It may be possible that it will give you a same value, but fx should be fx is real number. Okay, so a will be removed. So for this only I have a problem with x is equal to minus 1, because when you substitute x equal to minus 1, this function will not give you a real number. Okay, therefore the domain will be what? It is a collection of real numbers such that x is not equal to minus 1. Again you can write r minus 1, because at minus 1 the function fails to give you a real number. Alright, now in the similar way you can also calculate the range of this function by substituting y and solve for x. Then you will obtain that range of the function. Okay, so next we will look at the domain of the second example that we have considered. the second example, that fx equal to x square plus 1 all divided by x square plus 3x plus 2. Again, for domain of the function, denominator should not be equal to 0. So I will find what are the values of x for which the denominator is 0. So I will look at that the values of x for which the denominator, that is x square plus 3x plus 2, is equal to 0. The values of x for which this denominator is 0. Naturally, you can factorize it like this way. So x is equal to minus 1 and minus 2. It means that at these 2 points my denominator is 0. Therefore, they will be not in the domain, or they will be excluded from the domain of the function. So domain of the function is what? It is a collection of real numbers such that x is not equal to minus 1 and minus 2. So I can write in this way, that r minus minus 1 minus 2. Okay. So this is the way to calculate the domain of the function. And for range you have to follow the same procedure, because you have to select the values of the values of y such that the function is real. But what kind of function? X is equal to gy type function is a real number. Okay, so very simple example I can look at for the range. So in this way, very simple example we will look at that. For example, fx is equal to x upon x plus 1. I will find the domain of this function, x upon x plus 1. And one more lecture I will take on for the quadratic function, because that function is very important to important polynomial function, quadratic function, to find the domain. Domain is a collection of real numbers, so there is no problem in finding the domain. But for range there may be some problem. Therefore, so for example, that y is equal to x upon x plus 1. So I will calculate the value of y. So xy plus y equal to x. Okay, and I will simply calculate x. So I will take x common. So this will become y minus 1, and this will give you minus y, and this will give you y minus 1. Okay, just like this, x y minus 1 is equal to minus y. So the value of x is what? It is minus y upon y minus 1. So again the same thing, or you can just, so y should be what? It should not be equal to 0. So y should not be equal to 1. Therefore my range of this function is what? It is a collection y of real numbers such that it is not equal to 1. It means that real number minus 1 I can express. Okay, so for rational function, what we have learned how to find a domain of the rational function and how to find a range of the rational function. Okay, so on the next turn we will consider few examples of, especially of quadratic polynomial, so that you can have the idea of how to calculate the domain